待たせいたしました。それでは再開いたします。続いての基調講演は、接続機能を持つスマート製品や拡張現実が変える IoT 時代の競争戦略と題しまして、 PTC 社長兼 CEO ジェームス・E・ヘプルマン、そしてハーバード大学経営大学院教授マイケル・ポーター様によるセッションです。それではどうぞステージへお越しください。
Well, good afternoon, everybody, and we're so pleased that you're here at this event today, PTC's Japan Forum. And I've, of course, been here in Japan many, many times, and I've come to believe that this topic that we're talking about this afternoon is perhaps one of the most important topics that any of us has to think about in Japan, but also in every other country. But Japan actually has a special importance of this topic just because of the deep strength of manufacturing in this country. And Japan is still a country that makes things, lots of things. And I think what we're going to talk about today is really how things are changing. This work is a result of more than 5 years of research that has been a collaboration between me and my team at Harvard Business School and Jim Heppelman and his team at PTC. It's a unique collaboration between kind of academic and practice. But I think that I hope you'll find this very powerful and very interesting. The reason I got into this topic is because I have come to believe that this issue of what we call smart connected products is actually the biggest driver of change in competition in the world today. This is changing competition in every business. Most obviously, it's changing it in product-related businesses, but we're also seeing that it's changing competition in service businesses. Because if service industries have smart connected products, they can compete in a different way. So what we'd like to do today is give you kind of an overview of the core ideas here. Drawing on our work, you see here, we've had 2 Harvard Business Review articles on this subject. We would encourage you to read those articles because today we're only going to give you the overview. There's another article in process on the topic of augmented reality, which we'll talk about a little bit today, but hopefully that article will be published soon. But I think the purpose of this session is to be a kind of an opportunity for us to learn together about a fundamental change driver in competition and strategy. So how do we put this in context? Well, what we see, I think if we look at the history of companies and of information technology, I think we can really see where we are today and why smart connected products, as we call them, are really a discontinuity. If we go back far enough, products were simply mechanical and electrical. And products were mechanical and electrical for many, many years. And in fact, you go back in history for centuries. They were mostly mechanical way back when, but then electrical got added. It was that way for a long, long time. Then IT became available. And the first stage of IT and even the second stage of IT were internal to the company. IT affected how the company operated in the value chain. IT was used to automate processes within the value chain. Automate accounting, automate order processing, automate design through CAD. The first stage of IT in competition was automating the value chain, using IT to transmit manual processes into automated processes, store data in databases as opposed to file cabinets. That was stage one. That produced a tremendous amount of productivity improvement. Then the internet came along, and we went to stage two, or phase two. The ability to connect and share information across processes led to a next stage of productivity improvement. Things like supply chain management, SCM, customer relationship management, CRM, where you could have a seamless connection, know everything about the customer, your relationship with that customer, the channels. You could bridge across those groups using IT. PLM, something in which PTC is a major player today, was made possible by the advent of the internet and the ability to connect across geography and across parts of the value chain. Again, a huge benefit occurred to companies all over the world in terms of productivity. Lots of information was collected that was never ever possible to collect in the past. Digital information about the internal activities of the company. All that was a huge step forward. But what we started to see perhaps 5 to 10 years ago, and even back even earlier in very isolated cases, was what we see as the third phase by which information technology is transforming competition, and that is the embedding of information technology in the product itself. Previously, it had been in the process inside the company. Now IT has embedded itself in the actual product. And what this is doing is it's changing dramatically what products can do, the value that products can create. And we'll talk about that. But this change in products is also having a feedback effect, again, on the value chain. With smart connected products, marketing changes, product development changes, manufacturing changes. The inside changes too, not just the product. And so let's talk a little bit about what a smart connected product is, and then why it matters, and how it affects the choices that you need to make in whatever company you're in to really take advantage of this new opportunity that has been created. Now, what I've got in my hand here, hopefully everybody recognizes this. This is a tennis racket. I learned earlier today that tennis rackets like this have been used for about 150 years. And for 149 years, these were purely physical objects. And most tennis rackets today are physical objects. But this one is different. This is a tennis racket made by a company called Babolat. It's a French company that was a pioneer in the third phase, in integrating information technology actually into the product itself. And what you see here is the technology stack that is necessary to do that. So it starts with hardware. And if I gave you this tennis racket, you would say, this is just a tennis racket. It feels like a tennis racket. It plays like a tennis racket. Everything seems the same as you would expect a traditional tennis racket to be. What's different here is actually in this handle is some software and some sensors. And they're really focusing mostly on the strings and there are accelerometers and gyroscope measurement sensors in here that can actually figure out, given the pressure on the string, they can figure out the nature of the shot, how hard the shot was hit, whether there was spin, whether it was backhand or forehand. The sensors allow one to measure a lot of things about how this tennis racket is actually playing the game. Okay, so it's a physical tennis racket. It still does its physical thing, but now it has information technology. Not only the sensors, but a microprocessor in here that can collect data generated by these sensors. This tennis racket can also be connected. Now, because of considerations of weight and battery, there's a small battery in here, but to keep the tennis racket fluent in terms of playing like a tennis racket plays, this tennis racket doesn't continuously connect to the internet. Instead, the control system in here is very subtle. You wouldn't even notice it. You can sort of open the back here, and I'm probably not strong. No, there we go. There's the back, and you can turn it on. And you can connect this tennis racket using Bluetooth to your cell phone. And then your cell phone will then connect with the cloud. So a critical part of a smart connected product is it's the hardware, it's the software, which includes some place to at least temporarily store data, and then there's a connection to connect this physical object to through the cloud into the internet to a server running somewhere. And what has that cloud got in it? Well, every smart connected product, the cloud has a database, some place to collect the data that comes off of the physical object that's being measured by the information technology, particularly the sensors in that product. There's an analytics platform to kind of run the algorithms that have to be run. There's an application platform on which to run multiple applications that are displaying or analyzing interesting things that the player might want to know. You know, for this game, how many different shots did I hit, backhand, forehand? How hard did I hit the racket? How many times did I hit the ball in the sweet spot? Every tennis racket has a sweet spot, is where you want to hit it. And if you hit it up here, it doesn't feel so good. You want to hit it here, you get more power. All those things an application could measure and display to the user, to you and me. And that's what applications are then running on that product cloud, and you can look at the results of those applications again on your cell phone or on your computer if you choose. That's what a smart connected product is. It has these pieces. Now, the product itself is generating data about itself, which is very, very important, as we'll talk more later. But this same stack can access other data from your business system, your CRM systems. Who is the owner of this racket? What do we know about the owner? We could add that information into the application. Also, information from outside sources. There's lots of information out there you can access over the internet. You can combine that information with the information generated by this product. So, for example, wouldn't it be interesting to know where you were playing, what was the weather, what was the temperature, what was the humidity? Might be interesting to know how you play in hot weather versus cold weather. Lots of interesting information out there that you could think about combining and analyzing to get insight into your game, into you as a player, and all kinds of things you might want to learn. This is what a smart connected product is all about. It's these fundamental elements coming together. Now, what does this allow us to do? What does a smart connected product allow us to do that we've never been able to do before? What's different here? And the answer is that there's 4 fundamental capabilities that smart connected products have that products have never had before. One is monitoring. With the kind of technology and sensors in the product, we can monitor how the product is being used. We can monitor its condition. Is it hot? Is it cold? Is it overheating? Is it vibrating? We can monitor where it is in 3-dimensional space. We can monitor all kinds of dimensions of that product and how it's functioning. And we can monitor through the product, we can monitor certain environment around the product. This is an example here on this slide of a pacemaker implanted in a human. And that pacemaker is a smart connected pacemaker. It can measure how the pacemaker is working, but it can also measure how the body is functioning around it. And it can take physiological measurements and transmit those. And you don't have to go to your doctor in order to get the diagnosis. The doctor can see this data in real time, continuously. And if something looks weird, the doctor can get an alert that says, gee, call this patient, bring them in, because something's going on that looks dangerous. Okay, so monitoring is one unique capability here. Second is control. With a smart connected product with software embedded, we can control the product in ways that we never imagined before. Lots of dimensions of the performance of the product can be controlled because increasingly the control is driven by software. It's not just mechanical. The control is driven by the software that's running in the product. And the fact that there's a lot of control driven by the software means that we can personalize and customize a smart connected product very, very inexpensively. You know, with a mechanical product, to customize it, to make it different, you have to use different components. You have more mechanical parts, more complexity. It's expensive to customize. But with a smart connected product, you can often customize for free once you build the fundamental platform. You can control remotely. You don't have to be there. You don't have to push a button. You can deal with hazardous environments. So the control capability goes up dramatically with a smart connected product. Number 3, with the data you have and the ability to control and the deep knowledge of what's going on with a product, you can optimize the performance in very, very important ways. Optimize almost any dimension you want by understanding what the data is telling you and tweaking and affecting the way the product is functioning or working. This example here is a windmill. And this windmill, you can't see it, but it's sitting in a whole field of windmills. And on this windmill are these big blades. And a smart connected windmill, which this is, can actually continuously modify the kind of angles and the orientation of the blades to maximize the efficiency of capturing the wind. And the wind can be changing every second, and the blades can be modifying themselves every second with a kind of analytical algorithm. And if there's another windmill next door, that other windmill is going to affect the way the air flows, and this windmill can automatically adjust to how that windmill is operating. That's the power of optimization that you have when you have all this data, when you can monitor not only the performance of the product, but also the external environment. You end up with tremendous improvements in performance. Tremendous improvements in performance, something that we could never achieve before when we just had a mechanical product. And then finally, you see how these things add up. Monitoring allows control, control allows optimization, monitoring, control, and optimization allow autonomy. And increasingly we're finding that products can have more and more autonomy, but that's built on the foundation of these other capabilities. And smart connected products are now, many products have some autonomy, And an interesting question is how fast we'll move to full autonomy and whether we really want to move to full autonomy. But the point is that that is a natural extension of this technology. There's one other interesting thing, though, that happens with smart connected products that we'll talk about here, and that is the question of what are the boundaries of the industry in which you're competing. How do smart connected products change boundaries? And that is a very crucial question we have to ask in almost every industry. This is an example of a farm tractor. And you can see, if you go back far enough, farm tractors were mechanical and electrical objects. And they'd been that way for a long time. That's the history. Now, you could then create a smart tractor, which had sensors in it and software in it, and you could use the sensors and software to improve the way that tractor operated in some ways, and how you could maintain that tractor, because you could understand if it was failing, you could make adjustments, or you knew what was going to break, so you could fix it ahead of time. So a smart tractor is better than a dumb tractor, and so tractors got better. Well, then we made the tractor connected to the internet. Then, of course, we had location and GPS, and that's kind of critical when you're plowing and seeding, to know exactly where the tractor is and to be able to be highly precise about how that tractor is moving across the earth and doing its job. So the smart connected tractor is better than just the smart tractor. But so far, we're still in the tractor industry. We're making our tractor better so we can compete against other tractor companies. But one of the fascinating things about smart connected products is it doesn't end there. Because, of course, if we've got a smart tractor that's connected, how might that smart connected tractor work with other farm machines? So on the farm, there's other machines. There are combines and sprayers and spreaders and all kinds of other machines operating on the farm. What if we could integrate and coordinate across those various machines so that the machine wasn't standalone? The machine was working together with other machines. You know, here's an example of that. This is a John Deere example. You see two combines. In the back of the picture are two combines. They are harvesting wheat in this case. And a combine, as it harvests, these combines are smart connected combines, and they are driving autonomously. They have an operator in them, because so far you can't take the operator out of a farm machine. The technology does not allow us to detect all the potential hazards. So for now, we have somebody sitting in the seat who can intervene, but actually this combine is driving itself. And it's harvesting. And it's driving very precisely because it's controlled with GPS, and it knows exactly where it is. And it's driving exactly where it needs to go to optimize the harvesting of the particular field. It's storing the grain that it's harvesting, but eventually the storage gets full, and then this combine says, I need to offload my grain. So the combine here sends a message to a grain cart, which is here being pulled by a tractor on the bottom of this picture, and says, I need someplace to, I'm ready to offload my grain. And the grain cart then comes and syncs up with the combine. So the combine is driving the tractor with the cart. Now, again, there's an operator in there, but the operator's just standing there looking at the data and making sure everything goes well. And you can see that those two machines are running together. They're locked together. And that allows very precise transfer of the grain, loading of the cart. And then when it gets full, then it says, I'm full. And then the combine says, great, goodbye. And off goes the grain cart to where it's going to unload, and the shipment supply chain is going to go on from there. This same story we can tell with other farm machines. And increasingly, farm machines are not separate. They work as a system. They have to be, they're connected to the internet, but they're also connected and optimized with each other. And the algorithms are not just for the tractor, the algorithms are for the whole system. So in this case, what industry are you in? Well, clearly you're not just in the tractor business anymore. Say you're in the farm equipment system business. But of course you can go even farther because there's irrigation, there's seeds, there's pesticides, there's fertilizer. And increasingly what we see in many industries is we see a system of systems where this information that we now have, this ability to control products in a very precise way, the ability to do algorithms that optimize across complex phenomena, allows the industry to broaden. There's more things that are part of the industry. And many companies, as we'll see later, have to think very hard about, what does this mean for you? Does this mean that we just stay a tractor company, or do we really need to play in the broader system? This is a fundamental challenge of smart connected products. So let me turn it over to Jim now and sort of take you one step further. And hopefully you're starting to see what the smart connected product phenomena is all about, but it gets even more interesting. Jim.
Thank you, Michael. So for those of you who had a chance to hear me speak this morning, I talked a lot about the convergence of physical and digital. And we heard again with the tennis racket about how this tennis racket is both physical and digital. And of course, the tractor and the system of farm equipment is physical and digital. And this led Michael and I to think a little bit and to say, maybe we're missing something here, because there aren't just physical and digital players involved. There are humans too. And I don't think, in most cases, the humans are going away. And that's because while machines have certain strengths or skills, and computers, digital systems, have certain strengths and skills, so do humans. So for example, a skill of a farm tractor or a combine harvester is that it's very strong. It can carry a heavy load all day long. It does not get tired, it does not get bored. It can work and work and work. So that is a strength of machines, mechanical, physical machines. A strength of digital processing is the ability to collect and process massive amounts of data and to do computation against this data at levels that humans can't begin to do. You know, think of a supercomputer trying to solve a difficult engineering problem versus a human trying to do it with a piece of paper. It's no comparison. But machines and computers really don't match up to humans in some pretty important ways, because humans have skills that to this point we've not been able to replicate with machines and computers. Humans in particular can deal with unexpected situations. They don't need algorithms. They can react and figure things out very quickly. Humans have physical dexterity. Humans are creative. Michael mentioned that the tractor must have a human in it, and that's because if some unexpected situation develops, there's a large rock in the way, the tractor doesn't know what to do, but the human does. The human might say, I'll drive around it, or I'll back up, or I'll move the rock. I sometimes say, what will happen when an autonomous automobile gets a flat tire? I don't know, because it doesn't have the skills to deal with that unexpected situation. It doesn't have the manual dexterity to jack up the car and remove the lug nuts to replace the tire. So rather than think about this as being a problem of just physical and digital, Michael and I, particularly in our latest research, have been thinking about how do we create a situation where the machine, the computer, and the human each bring their strengths to the table to get the maximum outcome. So that's what we're thinking about, is how do humans better participate in these converged physical and digital systems? And we realize there's a bit of a problem today, and that is humans don't get to participate in the converged system. So to come back to this tennis racket, which is a fun example, that's why we use it. This tennis racket collects a tremendous amount of data. But I can either interact with the tennis racket using a physical interaction, or, so if we're going to get humans to fully participate, we have to think of a new model of interaction. And this is what brought us to the idea that augmented reality would be so important to smart connected products. Now, augmented reality means to take digital information from databases in the sky, in the cloud, and augment that onto the human's view of the physical environment in front of them, to put information directly in context, hopefully in a graphical way. So I have a fun little demonstration I want to show you. And to do that, we're going to switch to this iPad, if you can bring up the display. And I'm going to run this piece of software that we call ThingWorks Studio. And I'm going to use augmented reality technology to look at this same tennis racket. And then I'm going to hit a button that says, show me what happened in my last game. And it's showing me the various ball strikes as they hit the ball. So I see that's a backhand, 54% power in orange. Here's another backhand with topspin, 44% power. Here's an example of a serve, 72% full power with topspin. Here's an example of a smash, 78% power with topspin. And so you see I'm taking the data that was collected by the tennis racket, and rather than putting it on my phone, I'm putting it right back on the tennis racket, which creates for a very interesting experience. And of course, I can look at other data. I can say, give me a synopsis of what happened during the most recent match and so forth. And then it would just give me, in this case, a 2D display. So that's the demonstration I want to show you. Now, in the end, we don't expect that this technology will run, for the most part, on iPads or phones. It will run on smart glasses, like the Microsoft HoloLens. And there are many others. But these smart glasses are getting better and better. And when you put them on and wear them, you see the physical world through screens that add digital content. So I would see what you saw when wearing these glasses and looking at this tennis racket. So that's the power of augmented reality when combined with smart connected products. Now, we're not really talking about tennis rackets. What we're really talking about is smart connected products in general. And the tennis racket's just a fun, simple example. Let's look at what happens when you're driving in your car. You're looking at the windshield and you see physical reality. And then you look down at your navigation system and you see navigation instructions. And then you look up at physical reality and you realize it doesn't really look like those navigation instructions. So you must study the navigation instructions, try to determine the scale of this information. Does this screen represent 1 kilometer, or 10 kilometers, or 100 kilometers? What do the heavy green lines represent? What about the other green shaded information? What does this mean? So I have to think about it, I have to remember it, and then look back up at the windshield and try to replay in my mind what it means so that I can act on this information. So this is the same way the tennis racket worked before I used augmented reality. How could I use augmented reality in this automobile example? Well, I could use a heads-up augmented reality display. So rather than looking at the navigation system, why don't I take that digital information and augment it onto the view of the road I have through the windshield? And then you would see something that looks like this, a converged physical digital experience for the human. So when I look at the world, I see the digital information that I need to see, that I should take a turn right here, but the information is shown on the physical view I have of the roads in front of me. So this is a powerful idea that will really change the way that humans interact with smart connected products and with systems in general that are physical and digital at the same time. Now, it's sort of interesting when we think about the technology stack that is behind this, because when we add augmented reality, we're actually further embellishing the technology that Michael introduced earlier. So we still have the tennis racket made of hardware and software, communicating with Bluetooth, sensor readings up to the cloud, where we're running applications, but we have a second channel, really a visual channel, that allows software to see the environment with some form of computer vision. Could be camera-based, could be LiDAR, could be radar, but some way to see what's going on. And then a database to help you recognize, what do I see? Oh, I see a tennis racket. And what information do I have about the tennis racket? Well, actually, I have a lot, because all of the sensor readings and so forth, the analysis of the game was done in the blue stack. So I can bring that information through into the green stack and use it in applications that are augmented reality visual experience. So Michael and I have studied this problem a lot, and we really see this strategy as being key to the way we'll interact with our factories, interact with our automobiles, interact with our homes, interact with our tennis rackets ultimately. It's really a powerful idea that blends together the best of man, machine, and computer. Now with that, I want to turn it back over to Michael and let him talk a little bit about some of the implications for competition that this brings us to.
Well, thank you, Jim. And again, I think this issue of how to connect to humans and how to make it possible for humans to get the most out of the information, but also for the technology to get the most out of the contribution of humans, I think this is something that's just beginning. You know, some of the other things we've talked about, perhaps, you've seen, you're familiar with, but this is just beginning. And the technology now is accelerating rapidly to allow us to do that. So all of us, I think, are going to have fun with this, and it's going to create a lot of opportunities. What augmented reality does is it actually augments the capabilities that the smart connected product has. It allows you to monitor better because you can visualize, you can see it, you can put it together. It allows you to control better because you can use the AR as a control device. You can do control through the AR. It allows you to optimize better because you can add insight into the optimization. So AR becomes a big piece of the overall smart connected product value equation. And I think we'll be talking more and more and writing more and more about this. And PTC is deeply involved in the enabling technology for actually doing this at a reasonable cost. But of course, the big question that we started with is, where does this smart connected product thing affect competition? How does it affect strategy? Is this just sort of a detail? Just something we have to learn how to do? Is it kind of operational? Or is it really going to shift the nature of competition? Is it going to affect competitive advantage? Is it going to affect how we think about our strategy and how we distinguish ourselves from our competitors? And that's a question that, of course, has very high stakes for all of us. And of course, the simple answer is this has a major impact on competition. Now, to understand that, here on this slide, you see the kind of industry structure framework that I introduced, some years ago to really think about industry competition. The concept that is often called the 5 forces. That to understand competition, you have to understand this set of forces. The nature of rivalry, what companies are competing on, the power of the customer, the channel, the barriers to entry, how hard it is to get into the industry. And what we find is that smart connected products change all of this in many industries. So, we see that the opportunities for differentiation change. Smart connected products create many new functionalities that are possible in service, in remote control, all kinds of things, customization. Hopefully shifting that rivalry away from just a commodity price rivalry. All of a sudden we got a lot of new tools with which to differentiate ourselves. No matter what competition has been in the past, we have a lot of new opportunities. So that's a big difference. What we find is that smart connected products, because much of the control and variation comes from software, not hardware, often reduce the complexity of mechanical components. You can have the same mechanical components and different outputs based on the software. So in many smart connected products, the mechanical complexity of the manufacturing process and the product goes down. Just think of the switches. What if you don't have any dials? What if you don't have any off and on switches? All of a sudden you save enormous amounts of complexity mechanically in terms of detailed components. Think of how the cost of customization goes way down because all of a sudden the mechanical dimension stays the same. The offsetting factor there is that all of a sudden you get much more dependent on IT vendors, not mechanical component vendors. So how do we think about that? How do we make sure that we have, that we protect our differentiation against these new kind of suppliers? Again, more opportunities for differentiation, more opportunities for segmenting the market. We can customize products in ways we never could before. Switching costs get higher. Switching costs are the cost of the customer faces of kicking you out. And if we're locked into that customer with all this information and all this complexity, and the customer is on our product cloud, all of a sudden we get tightly connected to our customer in ways that allow us, hopefully, to sustain that customer relationship as long as we do a good job. We may need less work from our distribution channels. If we can do a lot of things remotely in terms of service, we may not need dealers everywhere in order to be successful. So you can see that if you think about this technology and what it allows you to do, it starts to potentially shift the nature of industry competition. And there's a lot of positives that we've talked about here. But there's also some negatives. So let's just look at a couple of examples here. This is an example of a threat that's created by smart connected products. That technological capability. This is quite a well-known story. Many of you may know this case. Others of you may not know it. It's a company called Sonos. And it's a company that was, not an important company in the sound equipment industry. The dominant brand was a company called Bose. And now there's also Japanese companies in this industry, but Bose, at least has had a very, very strong position in this industry. So what happened? This company called Sonos grew up and recognized that all of a sudden you didn't necessarily need to put a CD into your music production device. Actually, instead, you could stream the music off of the internet. Or you could plug in your computer and play the music you had stored on your computer, okay? You didn't need that physical CD in order to play music. You could still do that. But these guys were really the first to understand the impact of the fact that you could stream wirelessly the music from some source beside having to have the music plugged into the actual player. And that opportunity allowed them to completely re-engineer what a music system looked like. By having this music source, and by having all the interfaces on the cloud, you didn't have a box where you were turning on and off and doing all the controls on the box. You could put the interface with the music system on your iPhone. And the combination of streaming and the interface on the iPhone meant that the actual product, Sonos's product, became hugely simplified with much less physical complexity and much more flexibility. It was easy to add speakers. You could just stick the speakers, and the speakers then connected, wirelessly to the system, and therefore you could add another room and another room and another room. And this allowed this company, which really started with almost nothing, to enter and succeed in an industry against a very, very strong competitor. Because the competitor was still doing it the old way. And they had recognized the smart connected solution to music. And it might be that the music quality was a little bit less than with the traditional systems, but these guys realized that it was pretty good. And you could hardly tell the difference. And unless you were a real audiophile, it was an easy choice to make. So this shows you how in this technology, if you are a leader, but you don't recognize what this technology can allow you to do, you can actually be at risk. When there was no way anybody would beat you at the old game, they might be able to beat you at this new game. So that is one of the complicated dimensions of this technology because it gives new guys a way to enter the industry. So that's a threat. That said, there's also many, many opportunities. And so to understand those, let's talk a little bit about how this affects strategy. And of course, strategy is about your position within the industry. How are you going to compete? How are you going to distinguish yourself? How are you going to be unique? And what we found is that with smart connected products, we have some new choices we have to make. And this slide illustrates some of those new strategy choices. In fact, we think these 10 choices, every company now in this world is going to have to face. So the first choice is in many ways the most obvious. With all this new capability, with all this new monitoring and control and algorithms and optimization and interfaces, what capabilities are you going to choose to offer? There are hundreds of capabilities now that you could offer. You could allow your customer to monitor, their water heater, in the basement and see if it's going to fail. But, the question is, does the customer really care about that? Will the customer really pay for that? And one of the big risks with smart connected products is there's so many things you can do that you have a tendency to do too many of them, and the customer really doesn't want them enough to pay for them. And you end up giving away all the extra functionality, raising your cost because it takes technology to provide this functionality, but actually you don't get paid for it. So this is a very hard choice. Of all this capability, what do we actually offer? What do we choose to offer? There's some very tough technical choices having to do with, where do you put the functionality? Do you put it in the cloud? Do you put it in the product? Do we have an open system or a closed system? Do we have a system that's just we control? Or do we open ourselves on and let other people hook themselves to our system? Depending on our circumstances, we might make a different choice there. If we're a very, very strong company with a very, very strong position, we might have a closed system. We might be able to survive. But if we're not, we better be ecumenical and have interfaces that allow a lot of people to connect to us. Here's a very interesting choice that has to do with, what of all this technology do we really want to try to develop? There's a lot of different technological components here that Jim showed you in those dual technology stacks. Do we want to try to develop that stuff ourselves? How much of it do we want to rely on outside vendors? When we rely on outside vendors, we may have a bit of a risk, that's going to be hard to differentiate. On the other hand, if we try to do too much ourselves, do we really have the skill in areas that often are far away from our core manufacturing expertise that has gotten us to where we are today? This is an example from BMW that's used a variety of partners with very specialized skills and technologies in order to put together their broad infotainment system. And you can see some key questions that they have had to address, and you will have to address in terms of your interfaces. And then, do we disintermediate our distribution channels? Do we keep our channels? Do we try to get rid of our channels? Because we may not need them so much anymore. We can do the service ourselves remotely. We don't need a dealer everywhere anymore. So do we make that change? And one of the most profound questions is the number 10 on this sheet, which is, do we change our scope? If we have been a company that makes HVA systems, and we end up recognizing that we are part of a smart building system, and our HVA system is going to get integrated with the lighting system and the water system and the electrical system in the building to optimize energy efficiency and things like that, do we need to go beyond our traditional business and get into new areas where we've never competed before? A lot of companies are having to deal with this question of scope. And here's another interesting example that illustrates several of these cases, which is Tesla. Tesla is really quite a leader in adding smart connected technology into the automobile. They have a lot of differentiation in terms of their designs, in terms of their automation that they build into their cars, the ability to upgrade remotely. And given their technologies, they actually decided we don't need dealers. Because we can do a lot of repair remotely. We don't need the customer to go to the dealer. We can do it overnight in the garage. The repair will come to the customer remotely, not having to go to a dealer. They don't need dealers to help. They've done without dealers to sell their product. When you go to a Tesla, somebody brings it to you and tells you what you need to know, and then off you go. You don't need to go to a dealership and have all that overhead. And the dealer, of course, not having dealers allows you to control the price, make the user experience for the customer very, very attractive. So Tesla has made that choice. Other companies, like, for example, John Deere in agricultural equipment, they've chosen to really stick with their dealers and integrate their dealers into the smart connected system, because they think having somebody local that understands local circumstances and local agricultural conditions is very, very useful to make the whole system work, for the farmers. So different companies will make different choices. The point I think we would like to make and bring to your attention is you're going to have to make these choices. As you add more smart connectedness into your product, as you have more AR applications for deploying the technology and integrating the humans, you're going to have to make more and more of these choices. And the companies that don't choose and don't recognize the choices are going to have a hard time winning. And of course, expanding the scope is the hardest choice. And now we're seeing companies like John Deere getting into the sensor business and getting into machines that they never used to make before, because they've become convinced that to optimize performance, they have to control the design of the various machines. And that's why they've spread their scope more broadly than their traditional definition of their business. So these are big, big, important strategic questions that companies are now having to make that they really haven't had to even think about in the past. So one final brief point here that I'd like to make and then turn it back over to Jim is the point I made earlier. Having smart connected products doesn't just affect strategy and competition, it also affects how we actually do business, how we do manufacturing, how we do sales, how we do service, how we develop products. In fact, smart connected products are reinventing the way the value chain really works. So let me turn it over to Jim to kind of explain how this actually looks in real life.
Okay. Thank you, Michael. So I want to drill down in particular in these three blue highlighted areas, because that's what's probably closest to what you do, and that is engineering, manufacturing, and service. And if we start just with a couple examples from engineering, how would smart connected products affect engineering? I mean, obviously you'll do more software and digital engineering, but also you might implement strategies like try to shift product variability from hardware to software. A good example I was personally involved with was when smartphones went from having keys to just having glass. Because when the phones had keyboards, then the keyboards had to be released in every language. We needed the Japanese version, the Chinese version, the Spanish version, the English version, you name it. So the same thing would apply to an engine. Maybe in the past, I would offer the engine at 4 different horsepowers. This is, again, a farm equipment example. And 4 different horsepowers used to require 4 different sets of pistons, cylinders, engine blocks, all of that stuff. But now I can produce one engine and just using software tweak the horsepower, effectively derate it. And I can sell you that engine at different horsepower levels, but have the efficiencies of only producing and servicing one configuration of mechanical parts. A second idea that we see a lot now is designing products differently for a different business model. I like this example with bicycle sharing, because all of my life I own bicycles, and none of them look like this. Because as cities, and I'm sure you have this in Tokyo, have moved to implement bike sharing models, you get very different looking bicycles, because these bicycles are designed to be shared. They're not trying to impress you. They're trying to be durable, trying to be trackable, trying to be, bikes that work well for a long period of time. So a very different set of design requirements. And then a third example I want to show you is maybe how you'd think about how AR could affect your design process. And we have a fun little example here of one of our German customers. This is a video, if we can start it. Maybe I need to start it. Here we go. So this is a customer, Ego. And you can see they are augmenting a CAD-based body onto a physical chassis. And then they'll try a couple of different configurations of that body. So they're taking CAD data off of the screen of the computer, and they're augmenting it onto the physical chassis. So that was the first one. And then here's the second one. So what an incredible design review experience to actually be able to take that data and bring it into the room with you at life size and combine it with a physical asset. So that was a quick peek at some effects on engineering. Let me talk for a minute about effects on manufacturing. So many of us have talked today about Industry 4.0 and smart manufacturing. And what we've learned here is that by combining data we can get from automation and control systems with sensors, with IoT and analytics, and even AR-based work instructions, we can run factories very differently and find tremendous efficiencies that will improve our production process. There were some presentations about that here at the conference today. A second effect would be to think about manufacturing as being open-ended. Maybe even the idea of discrete manufacturing is going away, because when products contain a tremendous amount of digital content, and that digital content can be changed 1 year later, 2 years later, 5 years later, well then, when are we done manufacturing the product? I mean, maybe never, because we just keep updating it. And so the whole notion of build it, ship it, and you're done is changing to an open experience. So he is holding a simulator, but sensors are measuring the location, the angle, the pressure, and the motion, and simulating what type of a weld this would create. So we can then evaluate the welding skills and coach the user, but we're not consuming any steel or any electrodes or any electricity as we do it. It's a simulated experience that looks and feels real because of augmented reality. And then let me talk lastly about some implications for service processes. If we could get this to go forward, thank you. So service maybe changes the most of all, because most service processes in most industries are tremendously inefficient. There's a fleet of products you are supposed to service, but in a lot of cases you don't have any idea what is happening with these products. Are they heavily utilized or not? Do they have problems? Generally, in most industries, you only know about the problem after the problem has occurred and there's a failure. But we now see service industries becoming much more proactive and focusing on preventative care, prevent problems from happening. So by analyzing data coming from a fleet of products, and by using machine learning and predictive analytics, we can begin to see problems developing long before they actually occur, and then we can intervene at a convenient time and prevent the problem from occurring. So that's a big change in the way service is done. A second thing is we can frequently do remote service. We can log into a remote product, we can run diagnostics, we can make changes, get the product up and running, implement a workaround. All kinds of things can be done by tweaking the digital content of a product, much as you would for a computer somewhere in your office building. And then a third example of how augmented reality can play a role, in this case, is around enabling the end user to do service and support. So this is a blood analyzer from a Japanese company named Sysmex. And this is the type of machine that your blood is put in to analyze. And this particular machine has a problem. So the hospital administrator, or the blood technician, has run a cleaning cycle, and the machine reports that that did not solve the problem. So now this user is going to have to do a procedure that they've never done before. So the augmented reality technology is going to coach them through the process. So the first step you need to do is to turn the machine off, so the power button's blinking. And so the blood technician turns the power off, and only when it's confirmed that the power is off do we go on to the next step, which is to loosen the thumb screw on this enclosure, and then to remove this sheet metal enclosure, then to remove the aperture cover, and then to get a brush or a swab and stick it in there and wiggle it around to clear the clog, and then put the machine back together by reapplying the aperture and then the enclosure and so forth. So we were able here, when we detected a manual procedure must be done, rather than dispatch a technician, we were able to actually coach the blood analyst through doing that process themselves, even though they had never done it before. And of course, that would represent a huge efficiency in the terms of the number of service calls and service technicians that you'd need to dispatch to keep a fleet of products running. So those were some examples of how processes are changing. The last thing we want to talk about is how organizational structures are changing. And for that, I'll turn it back over to Michael.
Well, thanks, Jim. And again, we're running out of time here, but let's just talk about kind of the last big topic. We've talked about what these products can do, how to connect them better to humans, and we've seen how powerful that is. With the augmented reality, a person that doesn't know how to maintain a product can actually fix it. We've talked about how the capabilities of these products are actually affecting competition, industry boundaries. We've talked about how the nature of work in the value chain is changing, design is changing, marketing, didn't talk about it, but marketing changes, service changes, manufacturing changes. But given all those other changes, it should be no surprise that not only do all those other things change, but actually the organizational structure changes. And we're starting to see this as we get more mature with the early leaders in smart connected products. The traditional organization structure has been in place for many, many years. This is how a manufacturing company looks. It's a functional structure. There's an IT group, an R&D group, a manufacturing group, a marketing group, sales, and you see the rest. And those are the classical functions of a manufacturing firm. And that worked really, really well. In fact, this structure has probably been in place for 100 years. The only difference is that now there's an IT department. There didn't used to be an IT department, but that IT department in the traditional organization is the IT to work on the internal stuff. ERP systems and all that kind of stuff. That's what IT did, okay? But in a smart connected product world, this structure actually doesn't work anymore. The boundaries between the traditional functions are evolving. The nature of coordination between R&D and manufacturing and marketing and service, all those boundaries are shifting. And what we've started to see is a organizational model that looks, that has some fundamental changes. The first is the kind of blurring and integration of IT and R&D. Those things are no longer separate. They're interconnected. Most R&D departments don't understand clouds and that sort of stuff and connectivity. Most IT departments don't know anything about products and how to design actual products. But now we have to integrate and connect IT and R&D. Companies do that in different ways, but that boundary is shifting. So that's one big change. Another big change is with all this data that we're collecting all the time, we can no longer let the data sit in each function. It's just too expensive and too complicated. And the skills required to analyze the data really cut across. So what we're starting to see companies have is really a unified data organization. The data goes into a unified place. There's often a chief data officer. We're seeing a chief data officer in a lot of companies that are playing aggressively in this area. who's responsible for making sure that data is properly stored and protected and analyzed and working in collaboration with the other functional groups, rather than every one of these functions trying to deal with the data and have the analytical technology to do the data analytics. We're now seeing a unified data organization in many, many companies starting to pop up. We're starting to see the need for almost a entirely new function. Jim talked about it earlier. In a smart connected products world, you don't manufacture a product, ship it, and then you're done. In this world, the product out in the field is tethered to you. It's tethered by the cloud. The cloud needs to be maintained and upgraded for that product to continue to function and deliver the value that it's supposed to deliver. You're connected to that product forever. And if your cloud doesn't work, all those products out in the field aren't going to work. So that's a disaster. What we're seeing is the advent of a whole new organization, which is sometimes called DevOps, Development Operations, which is a group that is responsible for the ongoing upgrading and improvement of the cloud, and making sure that software upgrades and other improvements are done seamlessly. We can't take the cloud down. We got to keep it running. We've got to make sure our upgrades don't disrupt all the products out in the field that are operating in our company. And there's a whole new group in many companies growing up to actually do this. The final big change we're starting to see is a group that's really focused on what is commonly called customer success. You know, when you shipped a product and lost touch with it, and it went to the customer, and you had no idea what the customer was doing. You could ask them, but you really had no idea. In that world, you know, the sales force sold the product, and then when they made the sale, you shipped the product, and then you were done. But now, you're tethered to that product. You have a lot of visibility on how the customer is actually using that product. And you can look and see whether the customer is getting the value from the product. Is the customer using the features? Is the customer doing the things that you've engineered for that customer to be able to do to get the value? And what we're finding now is in the smart connected products world, companies are taking more responsibility to make sure the customer is succeeding. And the reason they can do that is they have visibility. They have the data to see how the customer is doing with the product. And what we're finding is that you often need a sort of a dedicated group called customer success management in order to actually deal with that problem, work that problem, take responsibility for that customer success. It's hard to rely just on the sales force. The sales force is not engineered to do that. The marketing department really is not interested and usually able to do that. We need a group of people who have the skill set to really work actively with customers to ensure their success. So you can see that smart connected products are changing about everything. They're changing design, they're changing the value chain, they're changing how we compete, they're changing the strategy choices, they're changing the way we organize. It's still early. Many companies are in the very early stages of this. Even the companies that have been doing this for 4 or 5 years are still in flux. We spend a lot of time studying this and working with companies and integrating with them. This is early, and we have a lot to learn. But I think just to conclude here, we'd like to say, first of all, that this is the biggest change that is affecting how we compete that we see across the entire economy, by far. We see that this is tremendously increasing the possibilities for value creation. in a whole variety of ways. This really starts with manufacturing industries, but ultimately it spreads to service industries. Because service industries are using smart connected products, and when they have smart connected products, they can deliver service in a different way in a service company. A railroad operates differently today. A building manager operates differently. A logistics company operates differently because they have smart connected products all over their value chain. We also see some tremendous positives here in terms of social impact, environment, energy, health, safety. Smart connected products allow us to dramatically improve in many ways the social impact of our company and our products out there in many, many ways. And although this is going to affect the nature of work and what people do in their jobs, we think that it's also creates an opportunity for people without so much skill to actually raise their skill and do more skilled work. You know, you could see how a technician in a laboratory, a clinical laboratory, was able to repair a product. Well, that same technology that allowed that technician to fix their own product allows somebody with no real formal training to actually learn how to do very complex work through augmented reality, through this information that we have available. So we believe that this can be given the nature of this economy, given the nature of the manufacturing economy here, we think that this is a possible vehicle to step up innovation in this country and hopefully get Japan growing again. So we'd like to thank you for your attention and hope that you will continue to study and learn. There's a lot of material that we haven't been able to share. Please read the articles. Please engage with websites and PTC's talented staff. This is a gigantic opportunity. All of you is going to have to deal with it. The time to start, if you haven't already started, is actually right now. So thank you very much, and Jim and I are so pleased that you're here, and we look forward to this relationship continuing.
Great. Thank you. Thank you, Michael.